Hi, welcome to Mrs. Park's geometry class. This is chapter 1, section 7, three-dimensional figures. So last section we talked about two-dimensional figures, and today we'll move on to three-dimensional figures. Okay, so why do we learn this? Architects often provide three-dimensional models of their ideas to clients. These models give their clients a better idea of what the completed structure will look like than a two-dimensional drawing. Three-dimensional figures or solids are made up of flat or curved surfaces. So here you have architects looking at a model of what they're about to build. So this is a 3D figure. They're made out of solids, so they can get a better understanding what it actually would look like when they build it. Identifying three-dimensional figures. A solid with all flat surfaces that enclose a single region of space is called a polyhedron. Polyhedron. Okay, so they're made of polygons. So each flat surface or face is a polygon. So each side is made of a polygon, and a solid is called a polyhedron. The line segments where the faces intersect are called edges. So each line is called an edge. Okay. The point where three or more edges intersect are vertex. So each point is a vertex. Each side is a face, and each line is an edge. Below are examples and definitions of polyhedrons and other types of solids. So here are the examples. Polyhedrons. A prism is a polyhedron with two parallel congruent faces called bases connected by parallelogram faces. So here, a polyhedron with parallel congruent faces called bases are connected by parallelogram faces, and this is called a prism. Okay. A pyramid is a polyhedron that has a polygonal base. So the base is a polygon, and three or more triangular faces that meet at a common vertex. Okay, so this is a pyramid. Okay, and the bottom, the face here, the base is a polygon. Okay, so some that are not polyhedrons, a cylinder that has a circle for top and bottom, the bases are circles, are called cylinders. Okay, a cone has a circle as a base, and they meet at one vertex. Okay, and a sphere is just it's like a ball, has no faces, edges, or vertices. It's just a set of points in a space that are the same distance from a given point. Okay, polyhedrons or polyhedra are named by the shapes of their bases. Okay, so a triangular prism, because the bases have triangles. A rectangular prism, okay, they have rectangle as a base. A pentagonal prism, okay, it has a pentagon as a base, it has 5 sides. A triangular pyramid, it's a pyramid, but the base it has 3 sides, so it's a triangular pyramid. A rectangular pyramid, it's a pyramid but it has 4 sides on the bottom, so it has a rectangle as the bottom base. A pentagonal pyramid has a pentagon as a base, and it's still a pyramid because the sides are made of triangles. All right, reading math. Symbols can be used in naming the focus of polyhedra. The symbol, okay, it looks like a rectangle, so you read it as rectangle. Okay. This looks like a triangle, so you read it as triangle. And then circle has a dot in the middle, and that you read as circle. Right, identifying solids. Determine whether each solid is a polyhedron. Then identify the solid. If it is a polyhedron, name the bases, faces, edges, and vertices. The solid is formed by a polygonal face, so it is a polyhedron. There are two parallel congruent rectangular bases, so it is a rectangular prism. So here's a prism. The bottom base is a rectangle, so it's a rectangular prism. The bases are the top, bottom, left, right, front, back. Okay. So, oh, I'm sorry. The bases are MNOP. So this is rectangle, MNOP. That's the bottom part. And RSTQ. RSTQ, that's the top part. So those are the two bases. And all the faces are the top, bottom, left, right, front, back. So there's all your 6 sides. Edges, we're going to name all the lines. So MN, NO, OP, PM, and then RS, ST, TQ, QR. So that are all the edges, and then don't forget the sides where you have RM, SN, TO, QP. Okay, so those are all the edges. The vertices, you're naming just the points, so you have R, S, M, N, Q, T, P, O. Okay. Determine whether each solid is a polyhedron, then identify the solid. If it is a polyhedron, name the bases, faces, edges, and vertices. Okay. The solid has this B here has a curved surface, so it's not a polyhedron. Remember, poly has a polygon as a base. Circles are not polygons. It has 2 congruent circular bases, so it is a cylinder. This is called a cylinder. Okay. C. This solid is formed by polygonal faces, so it is a polyhedron because I have triangular, and that's a polygon if it's triangle. The base is a triangle, and the 3 faces meet at a vertex, so it is a triangular pyramid. The base is triangle ABC. Okay, all the faces are ABC, and then you have ADC here on the left. You have CDB here on the right, and in the back, ADB. Okay, so you have 4 faces. The edges you have, we can say AD, or DA, DC, DB, and then you have the bottom AB, BC, and CA are all the edges. And the vertices, you have A, B, C, and D. So you're just going to name all the letters. Okay, so here's your turn, numbers 1A through 1B. Determine whether each solid is a polyhedron. Then identify the solid. If it is a polyhedron, name the bases, faces, edges, and vertices. Okay. So pause the video, go ahead and do 1A and 1B, and come back when you're done. Alright, welcome back. A polyhedron is a regular polyhedron if all of its faces are regular congruent polygons and all the edges are congruent. There are exactly 5 types of regular polyhedrons called Platonic solids because Plato used them extensively. Okay, so Platonic solids, here's a text. Let's try to attempt to read these words here. We have a tetrahedron, 4 equilateral triangle faces. Hexahedron, or cube, there's 6 equal squares. Octahedron, 8 equilateral triangular faces. Dodecahedron, it's 12 regular pentagonal faces, or pentagonal faces. And then you have isosahedron, 20 equilateral triangular faces. Okay, so here we're going to stop the video here, and then we'll have part 2 to continue the rest of section 7. So thanks for watching.